Hi everyone, welcome back to the Coding and Analysis YouTube channel. And in this video, we're going to add the functions, Numpy functions Log1p and Expm1 to the XGBoost Regressor Code. And we're using the dataset with the lot sizes. There are no missing lot sizes. I went in and scraped the 30 more homes that were missing lot sizes, and I did the analysis in the prior video for those. But in this video, we're going to add the Log1p and Expm1 functions. So the purpose of what we're doing here is Numpy Log1p function compresses large numbers into a smaller and more manageable range without losing their relative differences. And the Log1p smooths out extreme prices. So our prices are ranging from 285,000 to homes in the millions to the top one, which is 6 million, stabilizing variance and improving model performance. That's what we hope to do. And then we use the Expm1 function later to ensure accurate reversal of the transformation. So we just have to think of it as the model learns to predict on the log transformed prices in the log space, not the original dollar prices. So anytime you want to compare predictions to the actual prices in the real world dollar values, we have to invert the transformation using the Expm1 function. So we start off with the log1p and transform it back to the Expm1 function. And all the while, the model is learning on the log transform prices, since those values are more manageable to learn on. It's compressing the large numbers into smaller numbers. We just have to think of it as like a zip file. We're compressing the $1 million to a lower number for the model to learn on. We start off with this train and predict to custom function with the parameters property, type, and features. We prepare the features along transform target right here. These are our features. Just to go back. Waterfront, bath, square feet, private pool, latitude, beds, year built, and so forth. So those are features our model is learning off of. And we use the numpy.log1p for the target variable, which is the sold price. We are transforming the sold prices right here. We reset the indices to preserve alignment right here, like we've done before. We split the data into 80-20, train and test, with the random status 42 for reproducibility. We make a new column called data split, and train and test are the two values in that column. We train the XGBoost model from our XGBoost library that we imported. These are the parameters that the XGB regressor model is learning on. We do a xgb.fit method, and this is the training data that the model is training on. We predict on the train test right here and apply the inverse transform back to dollars. So our testing, so this is the model's predictions right here. We have our Y predictions train, predictions for the training model, predictions for the testing model. And we're transforming back to dollars with the XPM1 function. And we also have to do an inverse transform for the actual Y target variable for the comparisons. So we have to use the XPM1 function for the actual sold prices, because those, as you can see here, we did a log1p transform for the actual sold prices. So we have to transform back those into dollars as well. So we transform right here. We print out the mean absolute error in dollar terms. Print out the feature importances. Predict all in inverse transform for output. So we make our predictions. The predicted price shows up. The predicted price is right here. Our model's predicted price, the actual sold price is right here. This is what is going to show up in the CSV file: address, data split, property type, predicted price, and price. And we have our empty Python list. We do our for loop and appending into the empty list all this information, all the data, and we create our data frame, all predictions. And here is the MAE results. Training MAE is 53,000, testing MAE is 260,000. Waterfront is the highest feature importance, 39. Bass is 28. Square feet is 12.6. Private pool 7. Year built is only at 2. Lot size only at 1.1. And when we filter for the test set only, in our data split column, we say it needs to equal on test. And we start off with the empty list, Python list. And when we run the for loop, it's going to create a list of data dictionaries. So this is our dictionary of data, and it's going to go into the empty Python list. Then we convert it to a data frame for easy viewing. Then we get the results right here. Our R-square scored is 0.8. The MAE is the same as up here at the top, 260. For the testing, it seems like the previous, when we just did the XGBoost Regressor without these two functions, the testing did a little bit better. Let me go back and look at that. So 260,000, and the testing for just the XGBoost Regressor was 233,000, so only off by 30,000. It didn't do what we really wanted it to do. It didn't improve the score, but it didn't make the score that much worse. It was only off by 30,000 for the MAE. And we can see here the chart. This is the R-square score for both the training and test, 0.971. The MAE is only 95,000. There's no homes that are way too off. Some are undervalued, some are overvalued. In our data split, mostly, yeah, even the training or the outlier 44518 Old Plantation Place, that's in the training. Admiral Court is the testing. Ocean Boulevard's testing. We create a new column, valuation div, our predicted price from our model minus the actual sold price that was transformed back to dollars. and you can see our most overvalued properties. Ocean Boulevard was 2.3 million. Our predicted was 3.2 million, so it was off by a large amount, 904,000. The 201 Maddie's Way up by 617,000. Destiny Way only off by, compared to these two, only off by 373,000. And look at the undervalued Harbor Boulevard. $1.6 million, and our model predicted sale price had 631,000, so it was off by 968,000. For the next video, I'm going to do an analysis, look at the variances, see if look at the large variances, the medium variances, and with the within range, and compare them with the XGB regressor, the first one that I did that didn't have the 30 watt size is scraped. The second XGBoost regressor that I did that did have the 30 value scraped. And I'll compare and contrast those. So I'll do that in the next video. Thanks for watching and see y'all in the next video. Bye.